Hello, I'm Fred Wubs and I'm an associate professor in numerical mathematics at the University of Groningen.
My name is Gerard Goldhoorn. I'm a chemical engineering student.
Rudi asked us to take a look at his bicycle caravan. But before going into the details of this, so we just want to say that our university has been founded 400 years ago, and nowadays it has about 30,000 students. And the university is very active. It has a collaboration with a lot of universities around the world. Now back to the van. I like it very much. It has a very nicely streamlined shape.
But Fred, what does mathematicians know about shapes and aerodynamics of this van?
Now be careful. I'm an applied mathematician and specialized in numerical mathematics. So in this area we are constructing building blocks for flow simulation programs. These simulation programs are getting more and more important nowadays. In earlier days, in order to compute or to know the air resistance of such a fan, one just has to put it into a wind tunnel and do the measurements. And you could try all different kinds of shapes, so really should have rebuilt it a number of times with different shapes, and then he could study the air resistance. But nowadays you just have to draw it, and once you have drawn it, you give it to a computer program.
So you give some approximations to the computer program to make the best shape for the streamline?
Yeah, so I have an example over here how this is done. So here in this small area you see a drawing of such a fan. It's just oriented the other way around as here. But and there is a rectangular domain around it, so there the air will flow in that domain, and this domain will be covered by a mesh. And this mesh consists of a lot of small triangles. And the assumption in the simulation program is that the quantities which describe the airflow are kept constant in each triangle. So that is an approximation, because in reality this is not true, but far away from the van this will be true. But close to the van the flow will change a lot, and therefore you have to use small triangles over there. So it's very much the same as if you would take a picture, and if you have a picture then you need high resolution where there is a lot of change. And where there is little change you can do with a very low resolution. Also the same is that if you have a high resolution you have to store a lot of data, and you also have to do the computational work will be more involved. So we like to keep this amount of triangles low, but on the other hand of course we like to have accuracy, and therefore we would like to have a lot of them to make them small. So there's always a trade-off between accuracy and the size of the problem you can deal with. For this simple case, this is quite feasible.
So if Rudi wants to compute this van in this system, can he make some wrong approximations to make at the end the best shape for his van?
Yes, he could just draw various shapes. So I have an example over here. I just took a rectangle which has the same length as this van, and then in this picture you see the magnitude of the flow. So the green part is the flow is about 5.5 meters per second. You must imagine that you are sitting on this on the van, and so the air is coming towards you with the speed of the van, which is about 20 kilometers per hour. And what you see here, the blue region, this indicates that the flow is nearly zero over there, or otherwise spoken, you could say it goes with the speed of the van. And this means a large deviation from the undisturbed flow which is over there. So if this area is big, then there will be a lot of air resistance. Here I computed for this rectangular block there is 14 newtons of force due to air resistance. So, but if you change the shape, so here I have drawn something which looks much more like this van, then you see that the blue area is much smaller, and this immediately has this effect on the resistance and it is also about 16 newtons over here, so almost a factor, or more than a factor 2 has been gained, so the resistance is a lot smaller. So Rudi did a very nice job, and he did this computation, and it predicts that it is really a nice shape, this shape. But of course, this is a simple shape. In reality, so if we would look to complicated shapes like a plane or a ship, there may be appendages, and then the computation gets more and more involved, and we need supercomputers, and we need better approximations, etc. And therefore, we need smarter students to come to our university to help us to improve the simulation programs.
So with some simple clicks, Rudi can make his van more aerodynamic.
Yeah, it's only a matter of drawing and doing computations. So it's made quite easy nowadays.
Okay.
Yes. So
Awesome.
Rudi, thank you for showing us this nice van.